So let me start by explaining the method we're going to be using. This method is known as the AC method, meaning what you have to do is multiply the A value of the quadratic equation and the C value of the quadratic equation. What this does is enable us to convert the quadratic equation, which is usually a trinomial, into a polynomial, which with 4 terms. That makes it easier for us to use another method known as grouping. This is a method that we did before, but it's really simple. By multiplying both the A and C value, we get another term. What we want to be able to do in order to factor a trinomial of this magnitude is when we get the product of A and C, we look for factors. Factors that when we add them together, we can get the middle term B as a sum. You'll see more of this when we go over examples. Once we're able to do that, we can break down that trinomial into 4 terms. Once it's in a 4-term format, we can try to group it. Grouping will enable us to split the 4 terms into 2 separate terms. At that time, we can use another form of factoring, a lot easier form of factoring, known as GCF. Yeah, GCF will help us out a lot. What GCF stands for is greatest common factor. So, the first example we're going to be looking at will illustrate the principles behind the AC method. Again, just to reiterate what the principles are. Rule step 1. Multiply A and C. A and C can be given once you look at the standard form for any quadratic equation. What this procedure wants you to do is to multiply the A value, which is the value before the x squared, and the C value, which is the constant. Once you multiply that, you're gonna get a product. From that product, you want to be able to break it down to its factors. You're gonna need to look closely at the factors. List them all out, as we will in the examples. Once you list them, you're gonna look for the factors and circle the factors that, when you manipulate them in one shape or form, they will give you the B value. From there, you can separate those 2 factors, split it down the middle. And on the left-hand side, you're gonna look for the factor that most correlates with the A value. The right-hand side, the factor that most correlates with the C value. Splitting it down the middle, you're going to factor each side using the greatest common factor. Then what you're going to do is combine your coefficient and merge your other factors into just one. So the best way to illustrate this is to look at the examples. We're going to do 5 examples involving this, just so you get the hang of this. Remember, practice makes perfect. Before we start question 1, I want you guys to smash that like and click the subscribe button. Comment below your questions that you have, and I'll be sure to go over them, either in the next episode or definitely in a future episode. Your comments and likes help me make better content for you. Now, let's look at our first example. The first example says 5x squared minus 43x plus 24. According to our rules, we're going to multiply 5 and 24. Together, that's gonna give us a product of, 120. Then we look and list all the factors of 120. And you can see that here. Looking at that, the only 2 factors that would make sense for us are the numbers 40 and 3. Because 40 times 3 will give me 120. Which is the product of A and C. And 40 plus 3 in some shape or form, obviously in positive shape or form, will give me 43. You see it now working? This method, if you apply it correctly, makes factoring quadratic equation where the value of A is greater than 1 a lot easier. So please pay attention. Let's continue. Splitting down the factors, we're gonna put 40 next to the 5x squared. It's going to be 5x squared minus 40x minus 3x plus 24. We can split it down the middle, and then we're going to use grouping that we learned previously. We're going to group the coefficients, and then we're going to merge the terms after the coefficients. Using 40 and 3, we break this down using the greatest common factor. We have 5x squared minus 40x. The greatest common factor is going to be 5x. We pull 5x out of the expression of 5x squared minus 40x, and we're going to be left with 5x times x minus 8 on our left-hand side. For our right-hand side, we're going to do the same. We need to find the greatest common factor. In this case, it's going to be 3. And we're going to pull out -3 parentheses x minus 8. You can see that if I was to multiply both the right-hand side and the left-hand side, that using the distributive property, I would get back the term you see above. But in this case, I'm just going to merge my coefficients. My coefficients are 5x and -3. I'm going to merge them into one single term. After that, I'm going to merge the terms that were next to them, which is x minus 8. It's actually a duplication. That's what you need. You need to have a duplication in order for this to work. You have 5x minus 3 and you have x minus 8. The moment you don't have a duplication, you know that, yeah, you're doing something wrong. Look for that duplication as a telltale sign. So the final answer for that would be 5x minus 3 times x minus 8. Again, you have to go through with finding the roots by setting both of these factors equal to 0. That's going to leave us with two answers. X is equal to 3 over 5 and x is equal to 8. Let's try another to further clarify this method of factoring. The term is 5p squared plus 19p plus 12. Again, using our method, we're going to multiply 5 times 12, 8 times c. In this case, it's going to give us 60. Then we're going to break it down to its factors like so. What you see on your screen. The factors that will make the most sense for us to use are 15 and 4. So we're going to put it through the same procedure we did last time. We're going to put the 15 next to the 5p squared and we're going to put the 4 next to the 12, leaving us with an expression of 5p squared plus 15p plus 4p plus 12. We can split it right down the middle. Then we're going to use GCF once more and find the greatest common factors on both sides. The greatest common factor for the left-hand side will be 5p, meaning that 5p can go evenly into the expression of 5p squared plus 15p. And on the right-hand side is going to be 4 times p plus 3. Using the distributive property, we can see that when we multiply what's on the outside, the coefficients, with what's on the inside, we get back the term you see above. But again, we're just going to match our like terms. In this case, the 5p is going to match with the 4. So we're going to have 5p plus 4 in one expression and p plus 3 in another expression. So our answer is going to be 5p plus 4 times p plus 3. Again, as always, we solve for the roots. To get the roots, we have to use inverse operations and set it equal to 0. Like what you see on screen, leaving us with the answer of p equaling -4 over 5 and p equaling -3. Two examples. Again, guys, please smash that like. Help me create better content for you. Let's go on to the third question. This may take us all night. No, it won't. This is a lot faster than you think. The next problem we're gonna go over, we're gonna do something in addition to factoring using the AC method. We're also gonna go back and check to see if our answers are correct using the previous method that I discussed right here. So let's get on with it. Question 3. Problem 3 reads as follows. 3v squared plus 14v minus 49. So first things first, we're going to take the a value, which is 3, and the c value, which is -49, and we're going to multiply them together. We're going to get a product of 147. Now, with that product of 147, we have to find the factors, like we do here. The factors that, when we add them together, will give us back b are 21 and 7. So we're going to take those two factors and put them together separately, so we can create a 4-term polynomial. We're going to associate the 21 with the 3, the a, and the 7 with the c, which is -49, like how you see on your screen now. Then we're going to do, once again, the factoring known as GCF, greatest common factor. We're going to factor out the greatest common term in the first expression of 3v squared plus 21v. The greatest common term is going to be 3v. We pull it out and we're going to be left with 3v times v plus 7. That's our left-hand side. On our right-hand side, we're going to pull out the greatest common factor, once again, from 7v and 49, which in this case is going to be 7. So we're gonna pull out -7. We'll have -7 parentheses v plus 7. Again, the terms have to match, as you recall from the grouping video. And then we just associate the coefficients as well as the terms after them. So the coefficients in the first term is going to be 3v. The coefficient in the second term is -7. So we're gonna associate 3v minus 7 as 1. Then we're gonna associate v plus 7 as the second term. So the factor form is going to be 3v minus 7 times v plus 7. Now let's go ahead and check that using the box method that we learned last week. Again, we aligned the 3v minus 7 up top and the v plus 7 on the side. Then we go ahead and multiply the top by the side individually, and you'll see 3v squared in the first upper left hand box minus 7v in the right hand box, 21v in the lower left hand box, and -49 in the lower right hand box. So you'll see it performed like so. Combining our like terms here, once again like a previous video, we're going to be left with the original expression, which is 3v squared plus 14v minus 49. Then we go about finding the roots. Find the roots. Again, we set each one of our factors equal to 0, like you see here, and then we solve for v. Our expressions, our answer for this problem will be v equals 7 over 3 and v equaling -7. Third problem done with a check. Check method, again, I didn't do for the first two. I'll do for 2 here, and that's what I'm gonna leave for you guys to do. So problem number 4, 5p squared minus 52p plus 20. So again, the AC method, we're multiplying 5 times 20, which is going to give us 100. Then we go about getting the factors of 100, as you see here. We then choose the factors that will add up to 52. In this case, those factors will be 50 and 2. Pretty simple, right? Then we go ahead and associate those factors with both the A and the C values. The 50 is going to be associated with the A value of 5, and the 2 is going to be associated with the C value of 20, positive 20, like you see here. In this expression, we're going to factor out the greatest common factor. The greatest common factor on the left-hand side will be 5p. So that's going to be taken out of the parentheses, leaving us with a term on the left-hand side of 5p times p minus 10. Now you know that the p minus 10 has to be duplicated on the right-hand side, and the greatest common factor for the right-hand side is going to be 2. We pull out 2, not just 2, but -2, and we're left with p plus 10. So we have the coefficient of -2 on the right-hand side being pulled out of the parentheses. So it's -2 parentheses p plus 10, leaving us with a final expression of 5p minus 2 times p plus 10. Let's go ahead and put it back in the box to see if it all multiplies back up to the top expression. So we can go ahead and do that right now. As you can see for the box method, after we combine our like terms, we're going to be left with the same exact expression you saw above, which was 5p squared minus 5p plus 20. Check. So we know our answer is correct. One more thing we do is go about finding the roots. You guys know how to do it from there. You say 5p minus 2 equaling 0 and p plus 10 equaling 0. You're going to be left with 2 answers. P equals -10 and p equals 2 over 5. Fourth answer completed. You see guys, it's not that hard. It just requires a little bit of time and patience. But this method is actually faster than the previous method I showed before. And with diligence and practice, you can get it too. It's pretty simple, and everybody's capable of doing it. Don't let anyone ever tell you that you can't do it. Don't let anyone ever tell you that math is hard. Math is as easy or as hard as you make it. Always keep that in mind. Enough lecturing for me. Let me get back to problem 5. Back down. The final problem, guys, is going to be 2m squared plus 3m minus 27. AC factors found like so. The factors we'll focus on are going to be 9 and 6. We're going to associate the 6 with the 2 and the 9 with the 27, like so, leaving us with an expression of 2m times n plus 3 minus 9 times n plus 3. Associating our coefficient and merging the other term together, we're going to be left with 2m minus 9 times n plus 3. I'm going to leave the check up to you, and we're going to get a final answer after we find the roots of m equaling 9 over 2 and m equaling -3. So we're going to stop here now, guys. I'm going to continue on this topic of factoring because I think it's pretty important, and it's one of the most difficult topics that a lot of people struggle with. So in my next episode, I'm going to be going over perfect cubes, both the sum and the differences. Once again, guys, I'm AKG. I'm slowly but surely growing this channel, and I want to thank you for your support. I'll see you next time. Make sure to stay focused.